When we left off, we were here. In our last video, we had this distance formula, the 2 points, the distance between the 2 points on the chord and the distance between the 2 endpoints on the chord, and we said that those chords have to be the same length. These are the distance formulas set equal to each other. So their distances set equal to each other basically is what we are doing here, and we said that those distances have to be the same. Now, of course, what I'm going to do to simplify this, I'm going to square both sides and get rid of those radicals, if that's okay. So the next step, I'm just going to square out this stuff. So this first one, when I square it, it's going to be cosine u minus v, and it gets a little bit tedious, but it's not the worst thing. You're going to see in a second. It's actually not bad, especially if you know how to square your binomial. So that's this binomial squared. This guy squared is easy. That's going to be sine squared u minus v. Over here, we're going to get cosine squared v minus 2 cosine v cosine u. Sorry. And then over here, we're going to have plus cosine squared u. This thing's going to be the same thing, but, with with sines instead of cosines, right? So it's going to be sine squared v minus 2 sine v sine u plus sine squared u. And you can't see it because I'm zoomed in too much because I have this little tiny thing here. Let's see if we can get it in the shot. There he is. Okay, we'll zoom back in a second because actually I'm going to start combining stuff and making it a little bit easier to see. So I'm going to do something wonderful right now using my trig knowledge. So take a look at this one and this one. So again, I know I'm zoomed kind of far out, but everybody can see that this is cosine squared of some angle plus sine squared of some angle. So if I add a cosine and a sine squared of the same angle, hopefully everybody remembers from my Pythagorean identities that that is just a 1. Yes? And then I have minus 2 cosine u minus v plus a 1. That's what's left on this side because I combined these two to make a 1. Now over here, I'm going to do that same idea. I have a cosine squared v and a sine squared v. So when I add those together, of course, what do I get? A 1. And then I have a cosine squared u and a sine squared u. And when I add those together, I get a 1. And the only thing that I haven't dealt with here are these. So that's minus 2 cosine v cosine u minus 2 sine v sine u. All right. So when I combine these, I get a 2. And when I combine these, I get a 2. Sine v sine u. And now I can zoom in a little bit because now I have a little more room, a little more wiggle room here. And maybe you can see it a little better. All right, so I'm going to subtract the 2's from both sides and get rid of those. All right, those are gone. The last thing I'm going to do, and I'll be done, is actually divide both sides by a negative 2. So hopefully you've hung with me till now. When I divide by the negative 2, I get cosine u minus v, which is what I'm trying to write a formula for. My difference, my cosine difference formula here. And this one's going to be cosine v cosine u, and this will be a plus because we're dividing by the negative, sine v sine u. Isn't that wonderful? So what did we do here? We just derived this formula. In our last video, we looked at the angles and we looked at the arc lengths and we did all of that stuff. And we came up with this distance formula thing up here. And we showed that this will work for all angles. It doesn't matter what angles we pick. We just pick 2 random, generic angles and we plug them in. So that's the difference formula. So this is the difference for cosine. And why is it called the difference formula? Obviously, it's subtracting 2 angles. So difference in math means subtraction. All right. Now what I'm going to actually do is change this to the sum formula, and I'm going to do something a little bit sneaky here. I'm going to say let v equal negative v. Now why is that legal? Because, of course, in a formula, I should be able to replace it with any angle I want, right? I could put pi over 2, or I should be able to put negative pi over 2 in there also, right? So if I put a v or a negative v, the formula should still be true if everything that I just did was kosher. And, of course, it is legal. All of it was mathematically legal. You followed along and you saw. So what I'm going to do here next is just stick in a negative v for v. And why do I want to do such a cuckoo thing? Well, if I put in a negative v here, I get cosine u minus minus plus v. And so what I will be writing here is my sum formula for cosine. Isn't that great? So if I put in a negative v here for v, that means everywhere here I see v, I also have to put in a negative v. So I'm going to do cosine negative v cosine u plus sine negative v sine u. All right? Well, my even odd identities tell me that cosine negative v is the same thing as cosine v. So really, I'm just going to write him as cosine v because they're the same thing. And here, my sum and difference, not my sum and difference, my even and odd identities tell me that sine v is the same as negative sine v. So I'm just going to change that to negative sine. And this is the one that looks similar to what you'll find in your textbook. They might actually switch these around. I don't know. It doesn't matter because their multiplication is commutative. They might even switch these around because addition is commutative. But these are our two formulas, our difference and our sum. And what you probably will actually find in the textbook is something that looks like this. They like to write it this way to be concise because, you know, mathematicians like that. We like to keep it as simple as possible or as small as possible so that we love this plus or minus thing. The trouble is, take a look, when it was minus, it was plus, and when it was plus, it was minus. So to take care of that, we say cosine v cosine u, which of course is the same in sine v sine u. But because the plus has a minus, we write this one as minus plus, and we put sine v sine u. So when you see that, it's not that people just, wrote it upside down for fun. It's because it has to match these things, okay? Now, again, we could do this whole thing, and we could do, for sine and tangent also. But maybe we'll do those videos later. I'll just throw them in here for now so you can see. But we can get to these other ones using this formula, or we can go back and do angles and do the whole thing again. But again, just for time's sake, we're just going to pretend that I did, right? We'll say that I did, and I'll just give you the formulas for now. And if I have time, I'll put up the videos for the other ones. So this one is sine u plus v is going to be sine u cosine v. And this one will be plus or minus because they stay the same. And it will be cosine u sine v. So you have a u and a v and a cosine. And remember, the sine u has to be in the front when you have the minus sign. So it's just easier to learn them this way. And the cosines have to be in front because when you have the minus sign, it makes a difference. So I just learned them that way for both of them so that I don't have to learn a new identity for the negative one. And for tangent, again, if I have time, I will try to get you a video on that. But this one is going to be tan u plus or minus tan v. And in our next videos, we'll talk about how to use these formulas. Tan u times tan v. So this is going to be our sum and difference formulas for cosine, for sine, and for tangent. We're going to use these to evaluate angles other than our pi over 3 and our pi over 4 and our pi over 6, which are really the only ones we know how to do now. These will help us do a few more, and I'll show you those in our next video.